So, good morning, students. In the last lecture, we show that this grade of bold, which is 4.6, and from this grade of bold, we find out the ultimate tensile strength, which is Fu. The unit of ultimate tensile strength is Newton per mm square. And another is find out yield strength, which is denoted by Fy. Also, unit is Newton per mm square, right? So last time we find out this both 4.6 grade and 8.8 grade bond and its property ultimate tensile strength, which is Fu, and yield strength Fy, right? So I hope you understand that this grade of bold and its property. In the very next, what is the use of still washers, right? So steel washers is provided under the bolt head as well as under the nuts. So it provided to distribute the clamping pressure on the bolted member and to prevent the threaded portion of the bolt from bearing on the connecting parts. So in this figure, we understand that main there is a three important parts. First is the shank portion. Shank portion means first we go ahead with this head. So what is the meaning of head? Head is provided at the top as this shown in figure. This is a head, right? Uh, Now going forward, what is the meaning of shank portion? Shank portion is the portion which is below, exactly below the head, and above this threaded portion. So shank portion is below the head portion and above this threaded portion is known as, and it's a solid portion. In that portion there is no any threads, right? So in threaded portion only threaded threads are present, right? So whenever these threads are end or start, so this portion is called a threaded portion, right? Next is nut is provided below this washer as shown in this figure, right? Washer is this provided. This use of steel washers, these two uses are this wash faces, right? So washers are provided to distribute clamping pressure on this bolted connection, right? So, and the other is to prevent the threaded portion of the belt of the bolt from bearing on this connecting parts, right? So, there are this different types of parts. First is head, another one is a shank portion. At the end of this bolt, threaded portions are available. Shank portions are available in the middle section, and the head is at the top. And washer is provided. Washer is provided to distribute this clamping pressure, and it's also sometimes provided at the bolt head as well as under the nut. So the because of this grip is done, right? Now going forward, what is the meaning of turned bolts? Turn bolts are shown in figure. Turn bolts are very similar to these unfinished bolts. Here the shank portion is exactly as a hexagonal rods made from this hexagonal rod, looks like right, and it's primarily used in this light structures under the static load, such as small trusses, purlins, etc. And it is very expensive. That's why its use is limited and structured with no slippage connections. So first we see the ordinary black bolt. Second is turned bolt, which uses it's it's have a hexagonal rods in a shank portion, used in light structures under static load, such as small trusses, purlins, etc. And it's a very expensive and it's limited use because of its access, so that the cost of the structure is also increased. That's why uh, it's limited. Your use is limited, right? And it's also similar to this unfinished bolts. The next is ribbed bolts. Ripped bolts are shown in this figure. Head are given, body is given, and external screw threads are also given. So, round head is similar to this rivet. Raised ribs parallel to this shank portion. Ribs are provided in these shank portions compared to this rivet connection or other type of bolts, right? So actual diameter of this is a slightly larger than the hole. Actual diameter of this uh, bolt is slightly larger than the hole, so that it fits in the structure or in the hole completely. Tightly fit into this hole. It is popular because economical in material installation, right? So it's very cheap and it's economical in material installation. It uses when bearing type bolts slip under shear, right? So ribbed bolts, about of this ribbed bolts. Now next is a high strength bolts. So this high strength bolts is generally made from bars of medium carbon steel. The bolts of a property class of 8.8 and 10.9 are generally commonly used in these steel structures, right? So, bolt size of M60, M20, M24, and M30 are generally used in practice. This grade of bolts are maximum used in this industry, or generally in practice. This grade boards are generally commonly used, right? So these boards are provided with some property class, like a symbol U also show this in many type of sites, steel construction. You read that the grade is 8S, 8.8S, 10S, and 10.9. So this suffix S, which is denotes high strength structural wood, right? So 10 S on in this 10 is a grade, and S is denotes as a high strength structural bolts. Since these bolts are have tensile strength much higher than the ordinary black bolts, so the number of bolts are required at joint. Required number of bolts are less because of the high tensile strength, right? So in the very next, vibration and impact, we talk about this vibration and impact. So vibration and impact resistance of the joint are also improved because of these high strength bolts, right? High strength bolts with included in initial tension are called as this high strength friction grip bolts, right? So HS HSFG bolts are 50% costlier than the black bolts. The slip in this joint is eliminated because of this friction. In the case of friction grip bolts, the loads are transferred primarily by frictions, not by shear. Right? So surface in the contact must be free from rust, paint, mill, scale, grease, etc. So which would prevent a solid contact between the surfaces and the lower the slip factors. So that's why the sleeve-in joint is eliminated because of this friction. In this high strength bolts pre-tensions against the plate to be bolted together so that the contact pressure developed between the plates being joined. So it prevents relative slip when extra shear is applied. And the last, at least, higher shear resistance. It have some higher shear resistance. Now going forward, what is this advantage of bolted connections compared to this other riveted or welded connection? So it's noiseless and its fabrication is very quick. There is a no risk of fire, use of unskilled labor and simple rules, because there is always because in this bolted connection you have some bolts and nuts and tights by some not not using this special equipments for installation. It generally simply used by these unskilled laborers, which is easily assembled or installation process, right? Fast progress of work, because of this fastening or tightening, this process or progress of work is really fast as compared to these other connections. No special equipments or process needed for installation. It's not needed some welding machine or heating or cooling process, right? It's simply needs some bolts and nuts tightened by some machine, not used in machine, but some instruments used, right? So there is not special equipment or process are needed for installation. It's generally simply used by these unskilled laborers also. So it's easy to dismantle and reuse the material. If the bolt and nuts are dismantled, so it's easy to maintain or it's easy to dismantle. And these materials are also used as reuse this material because of hitting this materials. It's bolts are generally made from this carbon steel, right? So because of this made from steel, it's heating this material and also make some another bolts, right? So it's easy to reuse this material. So efficiency is 100% as compared to these rivet connections, which is 75 90%. Now what is the disadvantage of bolted connection? The first is no provision for expansion or contraction, that further, therefore, the greater chances of cracking, right? Uneven heating and cooling, members may distort and may result in additional stresses. Inspection is difficult and more costlier than rivets. Now we see that disadvantages of black bolted connection. So there is a slip of the joint in black bolted connection when load is applied. If the bolted connection becomes loose, their strength reduces considerably. When the large forces are to be resisted, the space required for the joint in this structure and the special locking device are required in situation involving fluctuating loads. What is this advantage of HSFG bolts, which is high strength friction grip bolts, right? So it is not allowed to slip between the elements connected. Requires smaller number of bolts, so the gusset plate size are reduced. Load is transmitted by friction only due to damping action, not subjected to shear and bearing. Deformation is minimized because it's a HSFG bolt, high strength friction grip bolt, right? Fabrication is noiseless, less number of labors are required, and no heating is required. Now, last we see that the bolt hole clearance, right? So this now we show that design criteria or design steps. These types of topics are generally used in the while you are calculating example. So remember the bolt hole clearance first, which is given in IS 800 table number 19 and page number 73. If you have a code or soft copy, you may open this when the lecture will be started, right? So made bolt holes are made generally made larger than the bolt diameter. Generally, for example, the nominal diameter of bolt is equal to a small dmm. The diameter is given, which is a small dmm. So diameter of bolt hole is equal to this nominal diameter of bolt plus clearance. Now some criteria are given this table bolt hole clearance. So size of bolt, which is small d, measured in mm, and the clearance is given. If your bolt diameter size is between 12 to 14 mm, so the clearance is 1 mm. If the size of bolt is between 16 to 22 mm, so the clearance is 2 mm. If the size of bolt is 24 mm, so clearance provided in the bolt hole is 2 mm. And if the size of bolt which is greater than 24 mm, so the clearance is provided in 3 mm, right? So for example, if diameter given is 16 mm, so the diameter, what is the size of diameter of hole? So diameter given is a 16 mm plus clearance provided, which is in this table 16 to 20 2 mm size of hole. Clearance provided is this 2 mm, right? So 16 plus 2 is equal to 18 mm. So we take this diameter of hole is equal to 18 mm. If suppose diameter is given is 13 mm, so for this size of bolt between 12 to 14 mm, clearance provided is 1 mm. So for 12, 13 and 14 mm size of bolt, clearance provided is 1 mm. So the diameter for 12 mm size of bolt is 12 plus 1 30 mm. For 13 mm size of bolt, 13 plus 1 is equal to 14 mm, and 14 mm size of bolt, the clearance provided is 1 mm. So 14 plus 1 is equal to 15 mm. Same as in this other diameter of bolt, other size of bolt. If a 20 bolt size are given 24 greater than 24 mm, so 3 mm clearance provided. But generally we use to generally the size of bolt given is between 12 to 20 mm size, right? So here 1 mm and 2 mm clears are mostly used. So we stop the lecture here. If you have any query, then contact me.